Hi students, welcome to the video lectures of software engineering. So today we are going to talk about unit 3, that is building the analysis model. So when I say building the analysis model, it talks about the requirement analysis modeling. Okay, so we'll try to explore various approaches that are used in requirement analysis modeling. And this requirement analysis is a very crucial phase, as you all know that, right? So we'll see what is there. Okay, so the main goal of this particular requirement analysis modeling is to understand what the system must do before we decide how to implement it. Okay, so if you observe this particular diagram, so here you can see analysis model, right? So which is acting as a bridge between the system description and design model, right? So that is how crucial is our analysis model is. Clear. So basically, the overall objectives and philosophy of analysis model is it must achieve three primary objectives. That is, first one is to describe what customer requires. Second one is to establish a basis for creation of a software design. Third one is to define a set of requirements that can be validated once the software is built. So these the analysis model must achieve these three primary objectives. Okay, students. So then purpose of analysis modeling. So basically the analysis model helps the developers and stakeholders clearly understand the functionality. Okay, and it serves as a foundation for design and testing. Third is it catch errors and gaps early in the process, right? So for example, if you take suppose an ATM, okay, let us take ATM project. So before we build an ATM software, so we model what the customer can do, right? For example, to withdraw or to deposit or to check balance, etc., right? So all sort of things has to be sorted prior. Then different modeling approaches. So what are various modeling approaches? So there are scenario based, flow oriented, class based, behavioral, data modeling, object oriented analysis. And of course, we'll dive into each topic in our forthcoming slides and all, as well as the other video lectures as well. So getting brief about each one of these. So first we go with scenario based. So scenario based, as you know, so this tells us, the story of the system from a user's perspective. Okay, it can be represented using use case diagram or activity diagram. Okay, next one is flow oriented, where we try to focus on how the data moves through system. Okay, how the data moves through the system. So how we can achieve this? Using the DFDs or CFDs. So that is nothing but data flow diagram and control flow diagrams. So next one is class based. So the class based modeling basically focuses on the data structure. Okay, and primarily it's useful when we move to design and implementation. Okay, and the diagrams with which it can be shown are class diagrams, their attributes and operations. Next is behavior. So where the behavior, the name itself suggests that how the system reacts to external events. Okay, as the name suggests, behavioral modeling. Okay, so the diagrams for this are state diagram and sequence diagram. Next one is data modeling. So here, how data is stored, how data is stored and related. So you all know about ER diagrams. This is how it is represented. Okay, entity relationship diagram we call. Entity relationship diagrams, right? For example, in a school management system, our entity relationship diagram will show the entities like student, class, teacher, and what sort of relationship that exists. Okay, like the student can select the course and check the attendance. The teacher can give the attendance or assign some marks to the student. Like each one, their roles, all those things can be represented using your ER diagrams. Next one, the last one is object oriented analysis. Okay, it combines the data and behavior into objects, where it combines the data and behavior of sorry data and behavior into objects. So diagrams, object diagrams, use cases, CRC also. Okay, class responsibility collaboration we call generally. So if you consider an example, if you are trying to have a project like a ticket booking system, where it contains both data like the seat number and the price of that particular seat, and the behavior is like to print or to cancel the ticket. So basically this object oriented is the widely used one. Next is data modeling concepts. So what is data modeling? So data modeling is the process of visually representing the structure of data used by a system. Got it? Data modeling is the process of visually representing the structure of data used by a system. So what exactly this is trying to tell us? The data modeling is, so what data will be stored, or how data elements are related, how they will be organized. Okay. All these things, simply to term this, it acts as a blueprint. Okay, this particular data model will act as a blueprint for designing, any kind of functionality. Let's say for a systems database. Okay, so that is how the data modeling acts as. Okay, data modeling is the process of visually representing the structure of data used by a system. Okay, so then what it defines? It defines what data will be stored, how data elements are related, and how they will be organized. These are the things the data modeling defines. Finally, it acts as a blueprint. So then what is the purpose of the data modeling? Okay, so when we say the purpose, as it is telling you what data will be stored, how data elements are related, how they will be organized, and all these things. So basically it is trying to provide, or it understands what kind of data the system should manage, and also it is capturing the relationships between different elements there, and it is also preparing a design for the database. And not only that, it also tries to reduce the redundancy, and also finally it improves the consistency. These are all the things which your data modeling is needed for. Okay, that is the purpose of this. So next we'll see entity, attributes, and relationships. So what are these? So let's try to break down each. So entity is a real world object. Entity is a real world object or concept. So what are those? For example, take a student or a book, okay, or any product can be your entity. So what is attribute? Characteristics of an entity is attribute. So what can be the characteristics of an entity? See, already we showed the entity as a student. So what does student have? So student as a name, right? So this can be an attribute, right? And a student can have a roll number, etc. Okay, then relationship is how entities are connected. So in the first example of entity, we took student and book, right? So let us try to build the relationship now of how these both entities are connected. Okay, so in library, the student borrows book, right? So this is the relationship. So here the AR model includes what? Rectangle for entities, ellipses for attributes, diamonds for relationships, and lines to show associations. Don't forget these things. Okay, students. So entity relationship model includes rectangle shape for entities, ellipse shape for attributes, and relationships are shown by using diamond shape, and associations using lines. Clear? So if you consider in our earlier example, students, books, all those things, student and book are entity, the relationship is borrows, and student name or roll number can be the attribute. Okay. So this is an example of the year diagram where you can see the employee, department, project, dependent. All these are mentioned. You can see employees having the, so you can see the entities, relationships, and attributes in this. Okay. Next, we move on to types of relationships. So we have here the types of relationships which are mentioned: one-to-one, one-to-many, and many-to-many. So for example, I'll tell you what is one-to-one. So for example, let us try to take the earlier example of a student and define this one-to-one relationship. So let me write: a student has only one ID card, right? So this is like one-to-one. So what is one-to-many? A teacher teaches many students, right? This is one-to-many. So what is many-to-many? So now let's say a student can borrow many books, and each book can be borrowed by many students. In the sense, I mean historically, okay? Each book by many students, okay? Then we have a couple of other relationships like cardinality and modality. So what are these? So cardinality is the same. So where it specifies the number of instances of one entity related to the another. For example, one teacher to many students, one teacher to many students. Okay, this is an example of cardinality. And modality is where it indicates whether the relationship is a mandatory one or an optional one. So classic example can be we have electives in engineering or in our course, right? So the student can opt for that particular elective or not. It's an optional or mandatory kind of thing. Next, advantages of data modeling. So it makes database design systematic and clear. It improves communication among stakeholders, reduces the data redundancy and anomalies, helps in efficient database and normalization, ensure the accuracy of data relationships. So these are the advantages of data modeling. Okay. Then what is object-oriented analysis? So object-oriented analysis is a modern and intuitive approach to software analysis that models the system based on the real world objects and interactions. Clear? So object-oriented analysis performs, or it is a process, okay, of analyzing a problem domain in order to identify their objects or attributes or behaviors and their relationships. Okay. So what can be the key things in what can be the key concepts in this object oriented analysis from the above definition are: it can be a class, object, attribute, method. Okay. So what is a class? Template for creating the objects. Okay. What is an object? Instance of a class. An attribute, properties of the class. Method, functions or behaviors. Clear? So these are all the key concepts of this object oriented analysis. Then we try to understand what are the steps in object oriented analysis. First one is to understand the system requirements is the first step. Okay. Second, it identifies key objects and classes. So when I say identifying key objects and classes, so earlier slide also we have written the key concepts of that. So here also it's mentioned like identifying the key objects and classes. So suppose classes, let us say a customer, okay, product or an order or a shopping cart, all these can be a classes, right? So in that, what can be the objects? A specific product. So let us say you are considering shopping cart or your order product, whatever, as a class. The product like iPhone 16 or iPhone 16 Pro Max or 15 Pro Max, anything that can be a object. Okay. Sometimes the name of the customer can also be a object. Okay. So then what can be the attributes of that particular project? Attribute is nothing but the price. Okay. The name of the product, example, all those things. Then methods of products can be, so methods, you know how to write methods, right? Like display the details, okay, or update stock. These can be the methods. Clear? Then define attributes and operations. Determine relationships among objects. Model scenarios using UML diagrams. All these are the steps in object-oriented analysis. Next, we have relationships. So relationships primarily are inheritance, aggregation, and association. When I say inheritance, so we all know what is inheritance. So a class derives from another. That is, it inherits the qualities, right? So for example, let's say there is an admin user who inherits from user. Okay. Then is aggregation. What is aggregation? As a relationship. Okay. For example, your shopping cart, which have products. Okay. Shopping cart has products. Okay. You have has a relationship. But then what is association? It's a general relationship. General relationship. For example, a customer places order. Okay, this is what the relationship association. Then what is the use of UML? UML, that is Unified Modeling Language. Yes, UML is the standard for modeling object-oriented systems. So these are some couple of important. Of course, there are a lot of UML diagrams. For example, it's given like this use case diagram, where we know the use case will show the user interactions. Then class diagram, where it defines the classes, attributes, methods, and relationships in it. And then it's stating the sequence diagram, where the visual interactions between the objects over time. Then the benefits of object-oriented analysis. Yes, models real-world concepts naturally. Okay, so whatever the things that we have discussed so far are so natural, right? Improves system modularity and maintainability, encourages reuse through inheritance, simplifies mapping to object-oriented programming languages like Java or Python, and enhances scalability and adaptability. Clear? These are the benefits. Hope you understood, students. Thank you.